The number one reason that crowns fail at the margin is because of poor impressions. Single most important reason that impressions fail is for poor tissue management to start with. And we go into that sulcus after we've pulled the cord, and as we circle around, we burnish that solution in against that cut connective tissue. I use the word burnish. You have to press against that cut connective tissue as you apply the solution. That gets the solution down where it does the job against the cut capillaries.
My name is Dan Fisher. I'm a practicing dentist and the CEO of Ultradent Products. We're a company which manufactures cutting-edge materials that raise the bar, improving, enhancing the quality of dentistry. I'm a lucky guy. I was able to go to dental school in the 70s, down in Southern California nonetheless. In dental school, I developed a passion for full mouth reconstruction. I came to realize early on, however, that the most important aspect of every restoration I placed was that it have quality marginal fit. Making a good impression was paramount, not just for the patient, but certainly for the quality of the restoration. The number one challenge for making quality impressions was to adequately control the bleeding, to adequately displace the tissue, so to be able to deliver the impression material to the sulcus subgingivally and in controlled, predictable ways. Our only hemostatics at the time were epinephrine, aluminum chloride. These left a lot to be desired. They didn't give us profound hemostasis. We would be lifting our retraction cord from the sulcus. We thought we were okay. We had already mixed our impression material. We'd start to deliver the impression material to the sulcus. It would trigger it to bleed. We'd be chasing the blood around the sulcus, trying to get the rubber to meet before the blood got there. Not predictable. We had impression materials that were totally adequate. They were accurate if used correctly. But our principal challenge was to be able to predictably control bleeding, displace tissue. I set up a lab in the basement of my home when I moved back to Utah. They had taught us IV sedation at Loma Linda. So after working on patients, I'd draw blood on myself. After a year, I looked like a junkie. I discovered that the ferric ion would instantly coagulate blood. I quite liked it in the ferric sulfate format, as both of these ions were common to the body. One couldn't be allergic to them. I learned, however, that I needed this coagulation process to occur inside of the cut capillary openings, not just as gobs and blobs on the surface that when one would rinse it off, it would start to bleed again. But it was a mess. Having discovered that I needed to get this solution inside of the capillary openings, I came up with the infuser, a little device with a little brush padded end that attaches to a syringe. This enabled me to, for the first time, achieve profound hemostasis, predictably and quickly. I took these inventions to large dental companies. They couldn't see the value, or at least weren't willing to pay for the value. And on that note, I discovered that if dentists were to be able to realize the benefit of this technology, we would have to start our own company. Ultradent was built on the backs of family. The first product was made on the kitchen table. We ultimately converted a 40 by 60 metal hay barn by the side of the house to a facility that passed FDA inspection several times. It was on this foundation that Ultradent was built, that it grew. We had 95 people working at the house in the hay barn until 1991. In which time we moved to our now location. We've been most fortunate. We've grown significantly since then. We've invented, brought out many new technologies. The UltraPack cord, that was a fun project that took a long time to create. You see, all of the retraction cords prior to UltraPack, they were either twisted cords or braided cords. with a twisted cord as the clinician would attempt to pack it with a packing instrument. One would slip between the fibers. Now, the braided cord eliminated that problem. However, a braided cord is very rigid. So as a clinician is packing over convexities into concavities and pushing down with their instrument, it causes the cord to pop out behind. The concept of a knit that would be made of interlocking loops acting more like a chain became quite appealing. We ended up using little knitting needles used to make ladies' pantyhose. We knitted a tiny little cotton tube, a little cotton pantyhose, smallest knitted cotton cord in the world. It took us 9 months to knit the first 1 inch of the number 0 cord. We started with the number 0 because if you could only make large sizes and you couldn't make small sizes, so what? And to make a small size knit, that's a challenge. You're using little cotton fibers about the size of cotton webs, and you're taking them with needles and pulling loops through loops, which causes these fibers to break very easily. Today, we make a 000, the smallest knitted cord in the world, if you will. So it was a fun project. It was a long time in development, but it has brought a great and a fabulous dimension for restorative as well as for crown and bridge dentistry. Astringent NX. I can stop bleeding on the aorta with Astringent NX. Now I'm being facetious, obviously. But as clinicians, we all experience those challenging bleeding patients. The patient who's on blood thinners, the hemophiliac, the patient who's been chewing on that broken loose filling for the last 6 months, you lift it out and they're bleeding like crazy. We must have agents to address these most challenging of cases. Astringent NX, it is more acidic than regular viscostat or Astringedent. However, it's critical that as clinicians, we do whatever we must do to stop bleeding. I often say that over time, soft tissues, they will heal. But leaky, pore-fitting margins will never heal, so be responsible, do what you have to do, but never perform adhesive dentistry, never perform impression making out of control. Astringent NX is for the challenging cases. The initial goal was not just to make a viscous hemostatic. Our goal was to reduce the negative acid effects that ferric sulfate would have on mineralized dental tissues. You see, all of the mineral astringents, be they aluminum chloride, alum, aluminum sulfate, ferric sulfate, they're all a little bit acidic. We would attempt to buffer this solution to get it so it wasn't as acidic, but every time we buffered it, we would lose effectiveness. Via having that fumed silica in the formula, one could apply viscostat to fresh-cut dentin. And even after 12, 14 minutes, the smear plugs would still be intact in the dentinal tubules. Whereas if one put straight ferric sulfate on the tooth surface, within 30 seconds, you virtually etch the tooth. Now Astringedent, it had other ingredients that made it so that it wasn't as aggressive as straight ferric sulfate. But nevertheless, our next level of improvement came with viscostat and the incorporation of fumed silica, making it one of the kindest hemostatics to be placed against mineralized tooth structure. Viscostat Clear is a more recent development in our hemostatic line. It came about on the heels of self-etching adhesives with a phosphoric acid etch, which is a tremendous cleaner. Any residual microscopic coagulum or otherwise is cleaned from the preparation. With the advent of the self-etch adhesives, which basically are no-wash adhesives, contamination can remain. Hence, if clinicians weren't careful in cleaning all of the preparation after using standard viscostat, they could have challenge is getting quality adhesion. They could even get leakage, which would leave stain underneath the restoration. So, with a lot of prodding from a number of clinicians, including Dr. John Kanka and some others, we came up with Viscostat Clear. It's not as rapid in onset as is the standard Viscostat, but for working in the aesthetic zone, many clinicians prefer it, and we use it the same way with the infuser. We use it with the knitted cord, regardless of what hemostatic, regardless of whether it takes a little longer in onset. The clinician always works with the guideline of obtaining profound quality hemostasis, and then they make their impression. Viscostat, Astringedent, the ferric sulfate solutions, oh, they must be the most difficult chemistries to add flavoring agents to, or sweetening agents to, for that matter. About 10 years back, we came up with this fabulous citric flavor. It gave kind of a lemony tang, but within 1 week it turned into orange citric soap. Not delightful. About 6-7 years ago, we finally found a mint flavor that held stable in the ferric sulfate solution. So today we have the option of the mint flavored Viscostat versus standard Viscostat, but the mint flavor is still not strawberry ice cream. So the basic communication to the clinician is keep it off the tongue. These are products that our company was founded on, that we became known for. They all were foundational products to perform quality operative dentistry, be it controlling bleeding, displacing tissues, quality etching, and the like. And hence, these are products that lap into many arenas in dentistry. They are not some procedure specific. They function with many procedures. So a number of reasons that they've been the mainstay. I believe Ultradent is unique as a company on a very fundamental principle, and that is that we work to maintain family values, but with a common goal. So with family values, we're driven to improve oral health globally, to improve one's health, to improve dentistry. We pride ourselves in creating new products and raising the bar and not being a Me Too company. So it's a juicy, rich environment to spend your day in.